And also, another detail is that the Indian there, the agave doesn't have the spike. They cut it. They don't let it get up. That is very, of course, for a botanist, that was a hinge, because agaves produce a whole spike of many thousand, 2,000, even 2,000 seedlings in the spike, and they know that. So if that happens, then no sugar will be down. So they were cutting that, so not letting it produce the spike. And to me, it's a very amazing story, because when I was here in University of Florida doing my bachelor's, I had to do a lot of chemistry, and the professor in organic chemistry told me that the first anticonceptive pill was done from agave. And I asked why, and he said, of course, these agaves will grow up to 15 years, then they reproduce and die. So during these 15 years, they are retaining reproduction. So this is how they isolated all this compound. But in this land, it's different. They let it grow, but when it's going to produce, so when it's going to produce all the offsprings, it's on the contrary. Everything is there to give a lot of energy to this reproductive effort, what we call in ecology. Well, I'll tell you later that I have a proof of that. They say, Pekaya, that they give this to women so that they have kids, and the women cannot have kids, you see? I have one 18 years old. I was drinking all of this, most, whatever, because I don't drink high, strong drinks, and they were teasing me. Oh, well, I tell you, this is very funny. The next one. So it was this law, which was horrible. This is how this was sold in the 19th century, everywhere, and even in these little bottles we found in these, dumping areas. But we couldn't believe. I mean, I'm not defending alcohol, like one Minister of Science told me. I am not defending the alcohol, I am defending the culture. And of course, they cannot sell anything else but the drink. Also, the drink was their main product to commercialize. Next one. And this is a very hard labor. And you can see, this is in the garden. Always being accompanied by trees and cactuses. The next one. So we decided to go and study the plants in natural conditions. This is my team in the field. It's very funny because agaves work at night, like aloes and the cactus. We have to measure 36 hours in a row because it's in the night where they are very active. Of course, it's a very hot environment. These plants are called calm plants, have evolved to work at night, which is cooler. The next one. And then we decided that we have to initiate a repopulation of agaves before they were destroyed. And so we collected a lot of this is one of the incredible stories with this lady up here. Without her, this could not have been possible. She's the leader of the town. Amazing. Okay, the next one. Also, we did a lot of biotechnology.
On the previous slide, it showed sort of how the soil and terrain look now. Is that pretty much the way it looked back in 1500?
Well, we think it will look less perturbed because there were no goats. The goats are very, the goats are, they're food, but the goats are very destructive. The goats, whatever, whatever comes and regenerate. So we have now a program of with the goats. The goats displaced the deer. We had small deer in that area. So the goats were brought and the deer didn't have what to eat, so the deer disappeared. So now we want to try again, also to look at the game, the fauna, the wildlife, and I think we will find a lot of interesting things with the wildlife. Maybe instead of always wanting to have cows and goats in the tropical American places, we should start looking at deer, agouti paca, and the other one is like a little pig, but it's wild. It's very good. So I think this is what I'm now finally getting some of the vets people to come with me and because they think, you know, if I say that I'm going to grow, to have a deer, they will say I'm crazy. You know, I told him that, you know, I've been told crazy for years, and now I'm not. The next one. So we also have a lot of, we study genetically, we did a lot of biotechnology there. Siguiente. Next. But we discovered something very interesting. These are all types of sugars present in the leaves that they are leaving aside, all these sugars. And if you look, fructose is one of the more common ones. In a succulent plant like that, you know, you're expecting fructose in fruits.
Yeah.
So that has been very interesting for us because they say that this fruit is, you know, now all the story that agave nectar is doing. It's doing its way, agave nectar. And agave nectar is not a nectar. Agave nectar is the sap of the leaf that are being collected in a very amazing way in Mexico. And we know now that this is the properties. We have a lot of sugars. Now we are doing also inulin, which is the sugar before fructose in the biochemical transformation, but it's very good for people with diabetes.
And anyone.
Yeah. So everywhere. Next one. So then we decided, okay, we have to work with the communities, and we have been doing many workshops and all of that. Right now, it's been a very nice interaction between us, and this is why we call science for the people, you know, because we started as ecologists, and now we are sociologists or anthropologists. I don't know what I have. Next one. And you know, the interesting thing is that this is made as it used to be made a long time ago, all by hand. All by hand. They don't fertilize these plants. They don't need fertilization. We discovered that they are associated with mycorrhiza, and they don't need, if you fertilize the soil, you kill the plant. That's the thing. But you see, it's a very hard labor, hand labor. They take the leaves. It's the same thing as they do in Mexico with tequila up to one point. Well, with mezcal more than tequila. But the nice thing is that they do this oven in situ, okay? And the leaves that they are removing, they're using to cover the heads that they are going to cook. And that is very different than in Mexico, very different. Those leaves then are thrown away. This is where we are working now. What do they need? If a plant to have this amount of sugar in the head, somebody has to do the factory, no? The leaves are doing. So the leaves are making all the compounds, sending down to the center of the plant, but still transportation is not that efficient. So in the base of the leaf there is many things that we are now extracting. So we are trying to use that. So they become this oven to me was an amazing story because we have all of these students from industrial engineering. They want to mechanize the whole thing from mechanical engineering. And then we went there and we measured, of course, we were measuring the temperature that oven initiates with is 600 degrees. Then it goes down to 105 and stays there 105 degrees for 5 days. That is amazing.
600 Fahrenheit?
Yeah, well, degrees Celsius.
Wow.
We could believe. Of course, they are having this. They call these stones. They call refractory stones. I'm still, I'm not very good in geology. They say this has to be these special stones that are the ones that are going to heat up so much. And then they pile up this because you would never think of this piling up. Something's going to cook, and they don't burn. They just caramelize a bit.
Yeah.
Okay. The next one. They keep doing all of that by hand. In Mexico, you have this donkey going around. You know, you have the agave piece, and then the over a piece of stone, and then the donkey is going around turning the grip. And here, no, they do it by hand. And they do it in wood, with a mass of wood. So it's all up to here organic, absolutely organic, but in their way of being organic. And they say it doesn't have to touch anything before it goes to fermentation. Nothing that is metal, nothing like that. So when they extract the juice, then they ferment it. And then, 7 days later, they go to the distillery. So it takes 18 days. So it's a hard labor, very hard labor. But what comes out of it is very good quality. So we decided to help them, and we set aside a lab in Pecaya. The next one. And we have the norm, which is an ISO norm now for Cocopuy. Pecayero, because it's from Pecaya. The next one. Then we have this, we're